Hi guys, welcome back to Bandermana Bricks. This time we're going to do something a little different. We're going to do a house tour in two separate houses, but they share a minimalist design and use a bioclimatic system. Curious? Watch this video until the end.
Thank you for thank you for thank what? Thank you for
Okay guys, now we're at Bio House. We're here with Kavi from Serasa Architect.
That's right.
How are you, Kavi?
I'm well, alhamdulillah.
Wow, thank you so much for letting us see this really unique house. Maybe you can explain what the overall concept is like?
Yes, it was mentioned earlier as biohouse. Actually, that's short for bioclimatic house.
Okay, yes.
Simply put, it's about our efforts to build in a more environmentally friendly way. Bioclimatic is actually a concept that architects often use. The goal is to make the house work more naturally. Through natural ventilation and natural lighting, we can reduce energy use and improve thermal and visual comfort naturally. To achieve that, of course, it's not easy, especially in a hot urban tropical context since we're close to the equator. Yes, the heat is very stable throughout the year. And then in urban areas, the buildings are already quite dense, so how can we maximize it? Well, actually, there's one approach. It's to test all the natural lighting we want to create, the natural ventilation we want to create. We test them first in a simulation.
Okay.
Now, this simulation in a software will later show the phenomena that occur in the design.
Wow, well,
There, later, we will optimize it so that the design provides better thermal comfort. For example, if the window turns out to be too big and it's too hot, we'll make it smaller.
yes.
So that's how the simulation can shape the design, if that's the case.
Wow, that's really interesting. So, in the end, the design is environmentally friendly too, right? Yes, indirectly. Okay, maybe we can ask about that. How big are the land area and the building area?
All right, ready? Okay, so what's interesting here is that there are actually two houses. The total site area of these two houses is 700 square meters.
Well,
One is the parent's house and the other is the child's house. That's the first thing from this family.
so which one is the child's house?
The one on the left.
The one on the left, right? Yeah.
Which one is your parent's house?
Okay, wow. Well,
In that 700 square meters, it's divided into 390 and also 310.
310? Yes, so it's actually very compact.
For a house with 3 bedrooms, right? But
It's 150.
Yes.
as for the parents' house, it's bigger and there are still children living there. The land area is 390. The building area is 250, so it's 100 meters bigger.
Okay.
It used to be even bigger in terms of area.
Yeah. Okay, when it comes to the facade design itself, I think I see a difference here between the kid's house and the parent's house. Maybe you could explain about the color mood and maybe also about the materials.
Actually, from the beginning, we met with the kid first.
So,
We started construction, it went on for 2 or 3 months, then we had the means to continue working on the project next door, okay?
so
They weren't done at the same time.
wow, so it's actually like an expandable house, right?
And actually, their parents kind of wanted to, see first how they would progress. If I think it's suitable, then they'd continue with us too. So
Turns out, thank God, it was a good match.
So the facade concept itself is very different. For the children's house, the client practices sustainable living. That's right, that eco-friendly lifestyle is reflected throughout the house. So it's also expressed through the facade, which is very simple, functional, and cuts out certain construction elements like paint. So to reduce the carbon footprint, we mostly use exposed cement for the walls. Meanwhile, for the other facade, which is the parents' house, since they tend to like things clean, parents usually prefer things clean, they don't like anything exposed. The design is more towards modern minimalism with very clean accent touches. Even the vent blocks are painted white as well. Now, in these two houses, even though they have different concepts, there are some common threads in the materials used. One of them is the Ulin wood used as a facade accent. So this facade is made of Ulin wood, which is resistant to weather conditions. So when we're here, even though the design feels different, there's a common thread that ties it all together.
Wow, interesting.
Something like that. For the carport itself, if you notice, almost all the paving in this house is porous. So in the front, we use grass blocks, and the entire carport uses grass blocks. Here, we're trying to implement zero runoff. Under these grass blocks, there are also a lot of biopores. And inside, there are two features that we'll talk about later, including porous concrete.
Okay.
It's a type of concrete that when rainwater spills on it, it immediately seeps down without pooling on the surface.
Okay.
And that's very environmentally friendly. We can keep a lot of water on our site before a big overflow goes out into the environment.
Wow. Well,
Up until now, because we have so many absorption areas with the permeable concept we talked about earlier, there's actually almost no excess water that we discharge
yes.
outside except for the front area, which goes down by gravity. Now, speaking of water, and since it relates to the facade, since we're at the front,
Okay, yes.
let me also tell you that these two houses use a rainwater harvesting system. Wow.
Wow, this is really interesting. It's rare.
We collect all the rainwater and reuse it. If you look at the facade of this house on the left, there's a gutter in front of it. The roof was intentionally slanted so the water flows down quickly. Flows, and if we look underneath, there's a pipe.
Yes, that part right there.
We'll run that pipe to the back.
To the underground tank.
Then it will be pumped up to the upper tank and later used for flushing the toilet and watering the plants.
Wow.
It's the same with this house, just a different slope.
Yes.
So later the slope will be to the right. And there will be a big funnel there for us to collect the rainwater.
Something like that. Wow, Mascavi has already made the audience curious. We haven't seen any of it yet. Lastly, maybe before we go in, earlier we talked about the carport too. This is the buffer. This area is the buffer area, and maybe the gate system as well. Yeah, maybe we can take a look, okay? So the gate system is split into two, right?
Yeah, so it's interesting, even though these are two houses, they are joined at the carport, but sometimes they have to sell the property or separate it. This can still be done very easily. You just need to separate them with a wall, and the gates are already separated.
So there are two.
This was the client's initial request, even though we're right next to each other. Sometimes we also have to think about how it would work if they were separated.
Keep it in mind for the future, okay?
Like that. More or less, the gate designs are the same. Both use iron. There's a standard one for the pedestrian gate, and for cars, we use a sliding gate.
From the outside, if that's the case, let's try to enter the first house first.
Let's go in, William.
Okay, wow. The design for the entrance itself is interesting too. It can't be closed off, but maybe they used iron.
Yeah, like we said earlier, the land area is 700 square meters. They have enough setback space. It's actually safe, so this house is kind of like being inside a small cluster. So we can be this open, you know. No need to worry about security since there's already another gate in front. So things like this might not be something we can apply to every project because it works here, so we apply it. So what I actually want to tell you is instead of entering straight into a foyer or living room, we want people to first arrive in a space that feels safe.
This garden, right? Yes.
This dry garden. Beneath this crushed stone, there are about 10 to 15 infiltration holes underneath, and also a soak pit to maintain the quality of the groundwater and also to absorb rainwater so we don't have to send too much water off-site, something like that.
Okay. Maybe besides the garden, I want to ask about the flow that's designed here. It looks like there's a pathway here.
That's right.
That's been created.
Yes, so earlier, as we mentioned, there's a surprising effect from coming in, entering this house. Maybe people think they'll go straight indoors, but actually, turns out there's a semi-outdoor area first, and there's a sequence. You walk through it first. You don't go straight into the house. Then from here, you turn and go into the house. So there's an element of surprise that we're trying to create here.
Wow, okay. And actually, it becomes an open plan as well.
That's right.
It connects to the living, dining, and kitchen areas, right? Yes, that's correct.
So let me tell you about the client's background as well. Because they're children, they have two kids, both of them are homeschooled since they were little, and I think one is now in high school. They were homeschooled from childhood through high school. Also, both of their parents work from home. That's why there's a studio here. Her husband happens to be a content creator,
Okay.
and actually his wife too. One of them makes content more often in the studio, and the other one is more often in the kitchen or at the dining table. That's how it is.
Well,
Because the client's profile is like that, the design response ends up like this. We made it really open like this between indoors and outdoors. In fact, if you notice, Mr. William, we don't have any doors at all. Yes, maybe the question will be, what if there's heavy rain or when it rains?
heavy rain.
So here we have an outdoor area, okay?
Blinder, right? There's an outdoor area. Use an outdoor blind.
We just need to pull this down and we can hook it at the bottom when the wind is really strong
That's right.
so it doesn't get inside.
Wow, something like this can really push the budget. That's right. Usually, windows are the most expensive part of a project.
That's right. Yes. Yes.
Well, sir,
With a concept like this, again, it goes back to their activities, their activity needs, right? This makes it more spacious, doesn't it? For their daily activities like studying at home, it feels much more roomy. This is an 8-meter span with no columns, multiplied by another 8 meters, so it's a square. Half of it is indoor, half of it.
it's like this too. It's very spacious and actually feels cool as well.
Yeah.
Maybe because it was built a bit far out for the overhang. Yeah. So,
Here's a little story, bro, since we're here. So all the bedrooms are upstairs.
okay.
Now, one feature that's also applied in a bioclimatic house is what's called a cavity wall. A cavity wall is a double wall, but there's a hollow space in the middle. Now, that's a natural insulation system that can trap heat better compared to a single wall. That's why the walls in this room have some bumps, you see?
And over here too,
Yeah, like that.
to help. That's the double wall one, right? There's a cavity in the middle, an empty cavity. An empty cavity, yeah, right.
To trap the heat, even though we still need a window, yeah?
For ventilation. Okay. Interesting. Okay, first floor, so we're going to the living area first, right?
Sure.
The living area was actually designed as an open plan, kept simple. The living, dining, and kitchen area also has a feature. There's a pretty high void here, right?
That's right.
This is a total of 8 meters, right?
All the way up, wow.
Okay, upper void. Well,
This is probably one of the features I want to explain as well in this bioclimatic design. Maybe you've often heard the term stacking effect, William. Okay, yes. Actually, it's a technique that goes way back in the Middle East. Even in the days of Mesopotamia, according to one source, they were already doing it. They built a lot of tall towers.
tall towers.
What is the purpose? It's to create a difference in air pressure. So at the top, the temperature is very high, but the pressure becomes very low.
That's right.
At the bottom, the temperature is lower and the pressure is higher.
We all know.
The wind basically moves from high pressure to low pressure. So this is actually a natural system that keeps the air moving through this house.
In other words,
We usually use the term cross ventilation.
or cross ventilation.
Here we're using what's called thermal ventilation. So it's ventilation that takes advantage of the thermal difference between temperatures, right?
Yeah, two temperatures.
So we can feel the air continuously circulating.
Yeah. Right. I also feel like it's not that hot here. Even though the light is bright and we get natural light, we don't really get that scorching heat.
Yeah.
So,
If you look a little closer, actually, why does the skylight chimney need to be made taller, William? So it's not at the same level as our ceiling.
well,
The purpose is so the heat stays up there. So it gets trapped above.
okay, well,
No, it doesn't go down below. Not to our eye level. That's why the higher the chimney, Actually, the stacking effect will be smoother.
Oh.
But we can't really make this house's chimney super tall. Yeah, that's right, because of regulations and so on. So this is the maximum we can create.
Okay. Interesting. We can check the details on the second floor later. Yeah, maybe we can go to the kitchen area. Yeah, the kitchen and dining area too. As for the kitchen set and maybe the dining table, are those provided by you or by the client, or how does it work? What about the waterman, bro?
Alright, for the kitchen, coincidentally, this is our design and it's produced by Serasa Interior.
So it's from the old house, yeah.
The refrigerator and almost all the loose furniture are from the old house, which we measured first to include in the design.
Yeah, but this one here isn't from the old house, right?
This one is new because it needs to fit the space, so we had to create a new one for this too.
Roughly, how wide do you think it is?
Actually, it's wide. This tiled area is only 3 meters wide. Add 1 meter of decking, so it's 4 meters. But because we have another 4 meters of garden over there, it feels like our living area is 8 meters. That's how it is.
Okay.
Actually, it's a visual illusion. Times what? Another 8 meters. So with the garden, it's really 8 by 8.
For the ceiling?
The ceiling is 2.4.
2.4, yes.
So the floor to floor is only 3 meters. We make the ceiling 2.4. Among other things, it's also for efficiency. That's it.
So it won't be hot, right?
That's right. The client has also, until today, probably lived with a domestic helper and the helper's family for about 10 years or more. So the space was intentionally provided to support them as well. Their needs here, right?
Okay, so
Here we designed the door so that it matches with the cement.
the exposed finish.
Even though this is actually HPL.
Oh, this is HPL.
HPL? It just looks similar, that's all.
HPL, and this just uses plywood, or you can use HMR.
Hi.
HMR, right? Moisture resistant board. Okay. So this is the mission. It's okay. There's someone, yes.
So this is both the dirty kitchen and Miss Rara's living quarters, right? Yes. The household helper who has been with them for years has her own room and bathroom. You can see the laundry area here, and this is also the drying area, storage, and the client's productive garden.
Okay, productive garden, sorry. Wow, that's really interesting.
There's also a chicken coop, and the eggs they consume also come from these chickens.
Wow, they have their own chickens.
Because they also compost, the compost they produce can also be used to support their chicken farming activities here, like that.
Is this system part of their bioclimatic design?
That's right. So as I mentioned earlier, this house uses a rainwater harvesting system. So all the rainwater is channeled. If you look here, there's a pipe, okay? And then this pipe will go down. Then here, there's a first flush system where the dirty water from the roof, which may contain dirt and leaves, is handled here first in the first flush system.
Okay. This is the place for the filter.
Yeah, that's right, because it will definitely carry dirt. So this is a simple filter that we can monitor, and later if the water gets dirty, we can dispose of it here.
Well,
The clean water will then be collected. We store it in the underground tank, and from there it's pumped up again to the upper tank. That's why there are 2 tanks above.
there are 2 tanks.
For clean water and recycled rainwater, we use the rainwater later for flushing toilets and watering plants, so we're more environmentally friendly.
So the water usage is also reduced, right?
That's right, exactly.
Awesome. Now let's take a look upstairs, okay?
Sure.
Okay, let's go. Bro, usually in the living room there's a powder room or a bathroom. Is there something like that here?
Yes. Like I explained earlier, the design has to be compact and make use of all the available space. So in this house, we use the area under the stairs. Oh, to make it a powder room.
Is this the powder room area?
That's right, we're aiming for a clean design. So this also uses HPL with a cement look. It's left exposed. It's more or less like this.
Wow, the door is interesting too. Is this a pivot door?
Pivot, that's right.
Okay, this is the bathroom, guys. If the door is a pivot, it means it can open inward. It can
open inward too.
It can open inward too, right? That means it's flexible.
That's right.
Okay, now let's go upstairs. Yes. So what material is used for these stairs?
Yes. So for the floor finishing, it's different, right? This one uses vinyl. vinyl from Taco as well. Actually, the idea is about how to break it up. So it's the transition between the first floor and the second floor. Now, there's also something interesting on this staircase, which is that we always place a cross vent block here. It's parallel or perpendicular to the chimney that we made.
Okay.
Yes, the purpose is to help the air inlet so it pushes the air out through the chimney. One thing we might need to discuss more scientifically. Why? Because we did this in a simulation first. Is it really true that all of that happens? With the simulation, we can predict whether the airflow through the CFD simulation can really happen as we expect. Originally, the design was actually a ramp for moving between the first floor and the second floor, but it turns out our ramp is blocking the air from going up.
Okay, like that.
So in the simulation, it was clearly a fail because the air couldn't get out. So in the end, we changed it. We just used stairs and replaced this part with a void, so the air was able to get out successfully.
Go up to the top. Yeah. Okay, this is the chimney that was made earlier as well. It's tall and you also installed windows, right?
That's right. Actually, it's a grill. The grill is set at a 45-degree angle so that rainwater from above doesn't get inside, but air from below can still get out.
It can go straight out. That's right. Is there a reason this one was made shorter?
Now, that's a good question. So, even though bioclimatic is the concept we're trying to push in this project, of course, as architects, we also have to think about the aesthetics because people still look at that. Imagine if this chimney was extended all the way to the front, there would be a weird bump on the front facade.
That's what we don't want, right? Okay.
So instead of having something awkward sticking out at the front, it's better to shorten it by a few meters. That way, the aesthetics are good, but the performance is also great.
Okay. So actually the airflow here might actually be a bit lower in terms of pressure. That's right. That's right. So it's possible. Yes.
Okay, interesting.
Because we're also making use of the stairs as well. The stairs don't need to be high. So just lower it. Okay. Okay. So what rooms are there on the second floor?
Yes. So the zoning, the layout is very simple. Upstairs, there are just 3 bedrooms. There's a master bedroom in the front, 1 bathroom inside. The kids' rooms are actually identical with their shared bathroom at the end.
Okay. Yeah. Maybe before we look at the rooms from this hallway, what material is used for the floor, Panlimas?
Yes, actually, this is Nairo granite 60x60. It's really because of the client's love for things that are bare and exposed. So the concept from the first floor to the second floor, even the tiles match the walls. Okay?
Okay. Yeah.
That's how it is.
All right. Are the doors and windows also from the old house? Yes.
One interesting thing too, Mas William, how can we build as economically as possible, including what we can reuse from the old house? That is the doors and actually the bathroom fixtures as well. So if you look at them, the bathroom fixtures are from the old house that we reused. Now, you can see these doors here. These are doors that have been here for a long time, but it's okay, we reuse them for the design.
Wow, it's a really raw design. Okay, about the rooms. Which room can we go into, sir? Yes.
We can enter the child's room here. So we'll also explain how the ventilation concept works. Okay?
Okay, this is the child's room. This is the twin of the actual child's room, right? That's right.
There are a few interesting things. First, even though it uses a thermal approach, we also designed cross ventilation, Mr. William. This is the facade I mentioned earlier. It's a cavity wall.
The wall is thick. Yes.
So if we look here, there's already 15 simanas, then another 15 simanas of empty space, and then another 15 simanas in front like that.
So the total is 45 ceiling. Okay.
Here we expect the air to come in from this inlet.
Well,
So where does it go out? Well, it can go out through the door.
then
It will go out to our chimney later. But if we need more privacy here, we've also accounted for that in the design with glass.
okay.
So we don't need a big space, right? We just need to open and close it like this.
Yes.
The air can already flow across and out through that chimney.
Okay.
3 by 3 meters is very compact. That's why we suggested having a bunk bed like this. So the bottom can be their study area and they sleep on the top.
That's right, because the ceiling also follows the roof, right?
There's a reason for that too. William, why is the ceiling slanted and high following the roof? So the question we always ask our clients is, what are their habits like? Do they always rely on air conditioning? Or are they actually comfortable with natural ventilation? Or are they okay with it? Every client is different. Some people truly can't live without air conditioning.
That's a bit difficult.
It's a bit hard for us to educate them, but since they share the same vision as us and want to reduce energy usage, turns out they're fine with natural ventilation, but in extreme conditions, we still need to have the AC on standby because we live in an urban area in Jakarta. So, from that answer, can you already determine what the ceiling design should be, Mr. William? If the client is really dependent on AC, don't make the ceiling too high, make it lower so the AC load doesn't get too heavy.
That's right.
But if they're fine with this kind of temperature and natural circulation, we actually design a higher ceiling so there's more air volume.
I see. Okay, yeah.
So just from 2 short interviews with the client like that, it should already be enough. Enough to determine the ceiling design.
The strategy, right? Yeah. Okay. So you can know, for example, what it's like if you want AC or what the potential is without AC. Sorry.
I missed one. So thermally speaking, hot air rises. That's the function of a high ceiling. So actually the heat goes up to the top. But at eye level, we don't feel it. Maybe we can share the simulation later so you can see it. The red areas are at the top, but at eye level, we don't feel it.
Yeah.
If it's still hot at the main eye level, that means the ceiling isn't high enough. We need to raise it again. Yeah. So we can see all of that in the simulation results.
So even if the air is hot, you don't really feel it at eye level because the ceiling is raised. It's raised even higher. Okay. Yeah. Wow.
That really depends on how broad the project is. How much is the budget? That's why the simulation detects it all. Even though it's just for an initial study and not for 100% validation, it really helps with the design.
Okay. Can we also see the master bedroom or?
Yeah, it's just because of client privacy. We're limited. Maybe one of the things we can still see is the shared bathroom.
Okay, let's take a look at the shared toilet, the bathroom, right? Yeah.
Okay.
Here's the way to the bathroom.
Yes, actually here we have a space that we prepared for them to store toiletries and some equipment. It's clean, right? So the space here is quite spacious before they enter the shared toilet. Also, for your information, this is the existing door that we reused and redesigned into a sliding door. Oh,
So you made a track system for it, right?
that's right. Then here is the toilet. And also the existing bathroom fixtures from the old house that we reused. There is enough lighting. And here there is also a shaft.
Is this the shaft? Yes, well,
We also created this shaft with the same finish as the wall. Actually, we can control the maintenance for the door.
it's easier to control it.
That's right. Now, if you notice, there are a lot of pipes here, not just clean water pipes, but also rainwater recycling pipes. The biggest pipe is the hardest one.
That's the rainwater one? Yes, take a look.
Okay.
So for this house, the system is already here. So we can also see if there's anything else we haven't mentioned about this house.
Okay. Overall, that's it. The only thing is that we were limited to the master bedroom earlier. Maybe next we can go straight to the house next door.
Okay, sure. Let's check out the house next door.
Okay, Will, as we go in, I'll explain both the house on the left earlier and this one on the right. The roof concept is still the same. It has to be quite steep, pretty slanted. The difference is the gutter will be on the side and then the water will flow to the back. We'll collect it with a big funnel.
But the splashing is more like this.
It's safer
It's safer, yeah.
because this is 1.7 meters from the overhang, right? Okay, off. That's why the structure is different from the other side. This one uses wide flange structural steel. Over there, it's light gauge steel.
Okay.
Because the span is quite large. That was the rainwater harvesting concept that we're also going to apply in this house.
Okay, we'll see the features later. Let's go inside the house. Okay. It looks like the entrance door uses a different material, or is it just the design that's different? Right.
Yes, the design principle is the same. It's still porous, so it kind of creates a surprise. Actually, people can see, but not very clearly. At the same time, it also helps with ventilation, so the air can still come in. The difference here is that we use perforated material, okay? Over there, they used iron directly, right? The perforated part uses angle iron, so we bend it inward to make it look thinner. So from the front, it looks nicer. That's how it is for this one.
Okay, so what's the difference between the child's house and the parent's house in terms of the view?
Yes.
From the entrance?
Yes, before we get there, let's talk a little about how there were actually some design changes that happened by accident, actually. Why? Because at first, the client's father, yes, his hobby is cycling. That's why we can see there are a lot of bicycles there. And even in the back, there's another bicycle parking area. But the father had an accident, so he couldn't cycle anymore. In the end, his hobby became riding motorcycles.
Okay, that's why there's a motorcycle here.
And actually, this wasn't well designed from the start, so there's no additional canopy for the motorcycle. The design also has some shortcomings like that.
This one shouldn't be here.
That's right, without this, the design would be cleaner. Same here, we don't go straight inside. We let the client experience the semi-outdoor space first, gradually moving into the house. Okay. Actually, the concept is the same as the house next door. But what really makes this garden different is the material. This is porous concrete.
So this is porous concrete, correct?
Yes. Just like the earlier concept, we apply the zero runoff principle to the surface design too. So the surface absorbs water faster without any puddles, and this outdoor area can also be used more comfortably because it's designed for easy maintenance.
Even the surface here isn't rough or painful to step on. That's right. Using gravel would be more painful, right?
That's right. Let's pour some water on it and see what happens.
Yeah, sure.
So we can see its performance.
Okay. Wow, so if it rains, it comes down right away. Yeah, the water. Let's take a look.
You can do it here again.
Wow, it disappeared right away. Yeah. Besides this garden, what's the difference on this first floor compared to the old house?
Now, if we look here, the roof has a funnel feature.
This one, right? Yeah.
So all the water from above is directed here. The funnel is fairly large because the water volume is high.
Yes.
Later, it will be just like before, channeled downwards. There will be a first flush. Then it will be pumped back up and spread out to flush the toilet and water the plants.
Okay. Like that.
Okay.
And this time, maybe the difference is that there's a partition now.
Yeah, it's interesting, and we can explain it as we go too. So this space is bigger, but why do we need a partition? Well, for parents, they really can't do without AC, Will. So we also need to think about it. Not everything can use the same bioclimatic concept everywhere. That's right. So one of the differences in this house is that we have a sliding door here. We have a sliding door and also an AC.
Okay, that's it.
Yes.
Yeah.
Even though we use it as little as possible, we still have a ceiling fan too. To help with air circulation, there's also a chimney above. So actually the concept is the same as the house next door. The air comes in through the inlet here. Then the outlet is at the top.
Yeah, the difference is that this void extends higher up.
That's right. This is actually better in terms of natural ventilation because it's bigger. Why? Because the heat will rise upward. The airflow will go even farther. The heat and the airflow will be even farther apart.
Okay, just like that.
Because here, in the parents' house, the master bedroom has to be on the first floor. Okay? It's different from next door, where the bedroom is still upstairs. Here, there are two bedrooms. There's the parents' bedroom. There's the father's room. And the mother's room is in front.
Okay, this is the father's room. Father.
Father's room is here. That's it.
Okay.
So there's one very simple material accent. The exposed parts are only on this side and that side, just for accent. The rest is painted white, which also distinguishes it from the house next door.
Expose
All
Okay, this is the father's room, his room. Maybe we can just take a quick look. Yeah.
sure.
We're just taking a quick look, and he also has direct window access to the garden.
Yes, in fact, it was designed that way. There's a sliding door here that leads directly to his bicycle.
Yes.
So it's true, from waking up or getting ready in the room, he really wants to go straight to his bicycle and then go cycling outside. That was the level of thought that went into it.
Okay, so this one also has a bathroom, right?
That's right,
There is. Oh,
the bathroom is inside.
the door is also a pivot door.
Pivot.
And is the material different or the same? The same as which one?
Yes, this isn't HPL, this is just gypsum.
Gypsum, right? Yes. Okay. Okay, next, maybe we can go to the next room.
Okay,
Mother's room, right? Yes.
let's explain while we walk, Will. Here, the difference with the house next door is that the furniture is new.
This is new, right? There's HPL as well.
This is HPL taco for some areas here. This is the clean kitchen, then this is the pantry for making coffee, and there's also a mini library. Now we're just entering
The room.
his mother's room. Now, if you notice, Will, we always hide the door, Will. If you go that way, you can't see the door. If you come this way, you also can't see the door. So the layout is kind of bent like that.
Okay, so it's for privacy. Privacy.
That's right.
Okay.
Come in. This is the room.
Wow, this is really interesting. Maybe his room has an opening at the top or something.
That's right. The light, yeah, the slit of light, we want to make it separate from the concrete above for the expression. And there's also a sliding door that opens to a sort of private garden. Yeah.
Yeah.
So the room is always connected to the outdoor area for a more natural circulation, okay?
Okay, maybe what else is there on this first floor, sir?
There's a service room in the back.
Yes. Okay, so that means every house also has a service room, right?
That's right.
Okay.
Let's go to the service area, Will.
It's in the back.
Before that, actually, there's also a bench area here. This is actually a lounge area, but since the bikes don't fit, they're also parked here. This is actually for family gatherings, barbecues at night, just to relax here, like that, before going into the service area.
So this is the service area.
Service area. The door also uses a pivot. This is the bedroom area, miss. There are two rooms actually.
That's right.
There's a toilet here and there. Please note, there's also a skylight.
Yes.
Lighting.
Lighting is really important, especially in a room like this, right?
That's porous concrete, right?
Miss,
And in the back, there's more porous concrete.
this uses porous concrete over here.
That's right.
Well,
So this is just like earlier, the water from the roof needs to go to the first flush first. What is the first flush? First flush is for us to catch the dirty water coming off the roof. Like there are leaves, dirt, and dust. We can catch all of that here first and throw it away. So it doesn't get into our first tank later.
okay.
It doesn't go into our groundwater tank. Only cleaner water goes in. Later, it can be used for flushing toilets and watering plants because the water is cleaner.
Okay. Wow, that's really interesting. Usually when we talk about houses, it's just about the design and how the rooms are shaped. Here, we're examining utility systems that are also important for overall utility quality.
Okay.
Maybe that's it for the first floor.
Yes, that's right.
Let's go to the second floor.
Okay. Before we go up to the second floor, Will, down here, we're also using the space under the stairs for a powder room. The only difference from before is that we're actually under the facade here. We're making use of the available space. Yes. And if you notice, we also added natural light down here.
Like that.
So it's brighter too. Bright. You don't need lights during the day. So besides aesthetics, the glass underneath is actually to make the house look like it's floating.
Yes.
We're aiming for a dramatic effect, but it's also functional for lighting. There's also a ventilation block here.
That's how it is.
So even though it's small, we really think about the quality of the space first.
Still, right? Still, that's enough.
Okay. Okay, there's also a shelf under the stairs to store things. So we make use of everything.
before.
Let's go up to the second floor. Okay, we're on the second floor.
The material is probably the same as the one on the other floor. It's the same, but it's in white.
That's right. Actually, while the house is different, there are also many similarities. That's right. Now, one interesting thing about this house is that because of the needs of one of the children, we use a ramp here for transfers.
Okay, yeah, that's right. Wow, this is interesting. Using a ramp is different, right?
That's right. And above, there's a skylight and also an exhaust chimney that we already explained in the house next door.
The concept is the same. Our concept is the same, yeah. But maybe the difference is that this corridor is used a bit differently.
That's right. Yes, before we get to the corridor landing, there's a shared bathroom here.
This is the shared toilet. Oh, this is the shared toilet, the shared toilet.
So here, there are two children's rooms, one here and one over there, and one guest room at the end.
Okay.
This is a shared toilet here. For the children's room over there, the bathroom will be inside. Okay. Now this corridor is interesting. If we look, the corridor is actually clean, but the furniture sticks out a bit to the front.
That's right.
We use this as a table. Since this is the parents' house, later the grandchildren and children will all gather here. So we need extra space for them to gather, right? Yeah. So if they stay over at their grandmother's house, they can also work here. There's an outlet underneath, so it's like a cafe, but you can still have a conversation with the people downstairs.
Yeah, that's basically it.
The floor has a 3-meter ceiling on the first floor, then 2.4 meters, and because it's a void, it goes up to 5 meters all the way to the top.
From top to bottom. Okay. Look, okay, let's go. This one also has a view. I see there's a window that can be opened.
That's interesting, Will. Earlier, we discussed that we're using a simulation. In our initial design simulation, actually, the window goes all the way up to the top.
Okay.
Because that's also the client's request. They want the design to look grander and more transparent, so it opens up to the outside. But the simulation showed it would be too hot.
Oh.
The window is too big, and since we're facing east over there, that's the issue.
Okay.
So we can't expose it too much either. So from that simulation, we saw a phenomenon. That means we have to solve it too, so that we achieve thermal comfort. That's why the windows are made smaller. Oh, there are still some for extra lighting, but the heat doesn't come in too much.
Okay, Mas. So we can talk in more detail downstairs, maybe? Sure. The living area, right?
Okay.
Okay, Mas Kapi. Yes, I want to ask, how long did the design and construction take?
Okay. Actually, the design was very quick because the client was also very cooperative with us. So actually, it was finished in about 3 months.
3 months was for the kid's house.
The kid's house.
The kid's house, yes.
About 3 months like that. After those 3 months, we immediately started building the house next door. The construction process only took 10 months.
10 months, so just over a year in total.
So in the second month of construction, we started designing this house.
The parents' house. So it was done in parallel, right?
Yes, in parallel. The design process took a bit longer, around 4 months. The construction also took longer because it was bigger. It took about 14 months. But what was quite special and challenging in this house, as you mentioned earlier, sir, is that you have a hobby of gardening in the back that requires special maintenance. The utility lines really needed to be carefully considered since we're using rainwater harvesting.
Yeah.
It's really important to pay attention to where you put the pipes and where the shaft is for maintenance.
Do you think you can share the budget?
Yes, sure. So actually for this house, the planning was at the end of 2022 and we started building in 2023. The price range is around 6.5 million per square meter. That's for the house next door. This house is actually closer to 7 million per square meter.
That's about it. Maybe if you want to see Masgavi's work, where can we see it? On social media or a website?
Yes, so far we're on Instagram. Our social media is sarasa.architect. Please feel free to check it out there. If anyone wants to ask any specific or more detailed questions about bioclimatic design, feel free to DM us. Or we can also help to give more insights like that.
Wow, that's awesome. Thank you, Masgavi, for sharing.
All right.
And if you have any questions, don't forget to comment below. Like, share, and subscribe so you won't miss the next video. Bye!